Hello, hello, and welcome to Lesson 4, GRE Ready for Prep. So hello to Andrea, hello to Crystal, hello to Jin, hello to Silvani, and I want to thank Silvani especially for showing up to office hours. That was a delight to give Silvani a private one-on-one office hours. The rest of you are welcome to come. It's not just Silvani's office hours, although it was a lot of fun. I'm not going to lie. So if you want to crash what I will call henceforth Silvani's office hour, please come Wednesday mornings. That is a lot of fun for me to get to know you guys a little bit better. And yeah, I charge $225 per hour when I do private tutoring. So Silvani got that for free, and I encourage you guys to get in on that sweet deal. So please show up office hours, ask any questions you like, and I am there to help. So I want to say hi to Whitney as well. Hi, Whitney. And I think we are ready to go. Okay, Silvani has lost sound and then got it back. So just wanted to make sure you guys can hear me. Yes? Type in yes or smiley face or greater than sign if you can hear me. If you cannot hear me, type in I love the GRE. Okay, great. Okay, everyone can hear me. You can say I love the GRE anyway. I love the GRE. So let's get going with, we're going to finish Quant 3 today. We're going to dive in head first into Quant 4, and then we are going to do some verbal. And I know we were a little tired on Tuesday, and by we, I mean me. I was a little sleepy on Tuesday, but I am pumped to see you today, and very excited to make all sorts of corny dad jokes. The entire lexicon, the entire oeuvre of corny dad jokes will be deployed in succession, and we're going to learn a little bit about standardized test taking too. So let's start the same way that we start every class, which is your questions. Any questions from the homework, from other standardized test prep, from anywhere you like, anything about the GRE, grad school, anything you want. What are your questions? Any questions? Crickets. We all have figured out the meaning of life. Oh, Crystal has a question. How many vocab words should we study in a day? That's sort of like a very deep philosophical question. There's so many possible answers to that. How many vocab words should you study in a day? Well, my short answer to that is that you should study, you should figure out how many, what sort of the corpus of words that you want to learn, how many you want to aim for. So if you have 200 or more likely 2,000, and you want to at least get some exposure to 2,000 different words by test day, you should be going over 50 words a day, because then you'll that's 40 days, and that's about how long you'll be studying. It's about 6 weeks. You could probably do 100 words a day. I think that's possible, but you should do 100 words a day and then make flashcards and then repeat, or use the Ready4 app. I think the Ready4 app really helps you learn a lot of words as well. The other things that I always recommend: read The Economist, read the Financial Times, read the Wall Street Journal. Those 3 publications are excellent sources of slightly harder than normal English words. So Economist, Financial Times, Wall Street Journal. Okay, some of you are admitting to not yet finishing homework. I will not say who said that. And I believe Julie has taken the other questions and answered those. So I will not answer any of the others. Okay, let's do some math. Let's do it. Okay, can you all see the screen? Example 5. This is where I said we would start off. So let's do it. So remember, we are talking about factors, multiples, and remainders. So we're trying to find I'm going to do this one in a minute with you, okay? But I want you to watch me do it, and I want you to listen, sit back, and listen to how I am breaking apart this problem, okay? And if you want to time me, you can time me. I'm going to do it in less than a minute, okay? So here we go. Pen. Okay. G is a positive integer that is divisible by 12. Great. So it's a positive integer, so can it be 0? Nope. Can it be negative 12? Nope. It's divisible by 12, so it has to be at least 12. But it might be 12, or it might be 24, or it might be 60, or it might be 120. Okay, so these are the numbers it could be. Okay, the remainder G, the remainder when G is divided by 24. Okay, if 12 is divided by 24, you get, so 12 divided by 24 is 0, remainder 12. 24 divided by 24 is 1, remainder 0. So I have no idea what the remainder is when G is divided by 24. The remainder when G is divided by 4, well, 12 divided by 4 is 3, remainder 0. And 24 divided by 4 is 6, remainder 0. So what is the remainder when G is divided by 4? 0. 0. What is the remainder when G is divided by 24? Who knows? So the answer is D. Okay? Got it? Any questions on that? Any questions? Blink if you are alive. I can't see you, but I assume you all blinked. Because if you haven't blinked, your eyes are very dry right now, and that's not going to serve you well on the GRE. It's just a fact. Okay, so any questions on that? We'll move on. All right, here we go. Prime numbers. What is a prime number? Prime number is a positive integer divisible only by 1 and itself. 1 and 0 are not prime. Here's what you need to know about prime numbers. The smallest and only even prime number is 2. I will repeat that. The smallest prime number is 2. Hey, is negative 1 a prime number? Nope. Why not? Because the smallest prime number is 2. Hey, is negative 2 a prime number? No. 0 a prime number? No. Why not? Because the smallest prime number is 2. The smallest prime number is 2, so any number that's less than 2, not a prime number. Negative 4, prime number? No. Negative 1.5? No. 1.5? No. 2 is the smallest prime number. That's it. It's the only even prime number. So look at the common prime numbers to know. These are really good to know. If you can memorize these, you're in good shape. Here's what you really need to memorize. These ones. You have got to know these prime numbers. 2, 3, 5, 7, 11, 13, 17, 19. You got to know that those are prime numbers. Okay? Helpful to know all of them, but essential to know these. Essential. Must memorize. Must, must, must. Okay? Good. Good, good. Okay. Go ahead and try this one. I'm going to let you try this one out. I'm going to give you 2 minutes. Starting now. Go. Okay, guys, we are coming back, and we're going to see how you did. Are you ready? Going to open the poll in 3, 2, 1. Go for it. Two more people. 2 more votes. 1 more vote. 1 more vote. You must vote. Compulsory voting. 3, 2, 1. Okay, whoever did not vote, you gotta vote. The only rule when I open the poll is that you must complete it. If you don't vote, I don't know how you're doing. So you have to guess, and it's good training for a timed test. When you have to move on. So if you're not voting, you have to vote. Australia has compulsory voting, so I invoke Australian rules. You have to vote, or I will fine you in a really bad way. Bad. Okay, so for the 80% of you who did vote, check it out. A lot of people saying E, some people saying C. Let's see if the majority is correct. So we have x equals 8p, where p is a prime number greater than 2. Greater than 2. So what's a prime number greater than 2? Could be 3, could be 5. Okay, so x could be 24, or x might be 40, right? So I'm going to try those. So how many different positive even divisors does x have, including x? So what are the divisors or factors of 24? Well, you got 1, you got 24, you got 2, you got 12, you got 3, you got 8, you got 4, you got 6. How many of those are even? 1, 2, 3, 4, 5, and 6. How about 40? 40, you got 1, you got 40, you got 2, you got 20, you got 3, no, 3 doesn't work. How about 4, you got 10, you got 5, you got 8. 1, 2, 3, 4, 5, 6. You all missed it. The answer is D. Okay. I'm going to stop since and please ask me questions. Where did you go astray? Where did you miss it? So please ask questions and help me, as they say in Jerry Maguire, help me help you. Help me help you. What is going on? Okay, so E. Can you explain how P is 3 and 5? Okay, P is a prime number greater than 2. So P cannot be 2. So you can't have 8 times 2. That's not going to work. It's a prime number greater than 2. So it could be 3, it could be 5, it could be 17, it could be 43. But I just used the 2 smallest prime numbers greater than 2, 3 and 5. Okay? And I just worked with that. If I used 7, I'm going to get 8 times 7, which is 56, and I will still get 6 even factors, 6 even divisors. Okay, what else? What are your other questions? How else were you led astray by this moderately difficult question? And how can I help you get it right? Other questions? We have never had a question where every single person in the class missed it. Okay, so divisor means factor. A divisor is a factor. That is something you will never ever forget when you see divisor. Same thing as factor. Okay. The other thing is what did I do? I did something called the factor rainbow. So there are 2 things I do to find factors. One is called factor rainbow, which is I write out the number, like 40, and I write out the smallest factor, which is 1, and the biggest factor, which is 40, and then the second smallest, I always try 2, okay, and 2 times what? 2 times 20, and then what's the next smallest? Is it 3? No, the next smallest is 4. 4 times what? 10, and then what's the next smallest? 5, and then 8. And then is 6 a factor of 40? No. 7 a factor? No. Now you're done. Okay, so that's it. That's called factor rainbow. And then the other thing I do is called factor tree. So factor tree is when you want to find the prime factors. So what's a prime factor of 40? Well, 2 is a prime factor, right? 2 times what? 20. And then you do 2 is a factor of 20. 2 times what? 10. And then 2 is a factor of 10. And then 2 times what? 5. So 40 is 2 times 2 times 2 times 5, or 2 cubed times 5. Okay? And when you want to know how many factors 40 has, let me teach you a trick. 2 cubed times 5 to the first. You see these exponents? Bring those down here and add 1 to each. And then you multiply 3 plus 1 times 1 plus 1. So 4 times 2. 8 factors. That's how many factors 40 has. Let me do another example. What about if you have 2 times 3 times 5? What's that? That's 30. 2 times 3 is 6 times 5. How many factors does 30 have? Well, I'm going to box each of these exponents. I'm going to bring them down. And I'm going to add 1 to each. And I'm going to multiply. So I get 2 times 2 times 2. 30 has 8 factors. Okay? Prime factorization and factor tree are the same thing. Same thing. Okay. Any other questions? Any other questions? So this right here, this is to find the total number of factors or divisors. Okay? That's what I'm doing here with the exponents. Okay? Any other questions? Okay. Made me nervous when you all missed it. Let's not do that again. Here we go. Let's move on to more problems. Okay. To find the prime factorization, you're looking for which prime numbers multiplied together give us the original number. So 12 is 2 times 2 times 3. 30 is 2 times 3 times 5. Cool. So start with the smallest prime factor. Create a factor tree. So this is what we just did. So what's the smallest prime factor of 24? So 2 times what is 24? 12. What's the smallest prime factor? And you put a circle on it. What's the smallest prime factor of 12? 2. So once you put a circle around it, it is frozen, it is ossified in amber, it cannot be touched. And you continue to deal with the right side. So 2 times what is 12? 6. And then 2 times what? 6. 3. 2 times 6 is 12. There you go. So you get 24 is 2 times 2 times 2 times 3, or 2 cubed times 3 to the first. Okay? That's it. That's all it is. Got it? Any questions? Any questions? No questions? Okay. Let's move on. All right, guys. Let's get this one. I'm going to give you a minute and 50 seconds. Go. Okay, guys, coming back. Let's see how you did. I'm going to open the poll in 3, 2, 1. Go for it. Two more people, you must vote. One more person must vote. Break the tie. One person is not voting. I am very displeased. Please vote. Vote. Okay, whoever is not voting, I'm not going to call you out, but stop it. You got to vote. Okay. All right. Still one truculent student not voting. The rest of you, thank you for voting, and you have split between B and D. Let's see how we do this. Okay. 180 over P is an integer, and P is a prime number. How many different P's can you have? All right, what does it mean to have an integer? So it's got to be a whole number. That means that 180 divided by this thing is going to produce. So what if you had like 180 divided by 120? Is that going to work? It's going to be 1.5, and that is not an integer. An integer is a whole number. A whole number. So, and P is a prime number. So 180, what's the smallest P you can have? What's the smallest prime number? The smallest prime number there is 2. So that works. You can have 180 over 3. That works. 180 over 5. That works. What about 180 over 7? Nope. 180 over 9? That's not a prime number. Trick question. 180 over 13? Nope. 180 over 17? Nope. 180 over 19? Blah, 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 blah. So I think it's just 3. I think that's it. How are we going to check it? Let's prime factorize it. So 180 is 2 squared times 3 squared times 5. Aha! So how many different prime numbers can we get? 2, 3, and 5. That's it. It's B. So for those of you who got B, excellent job. For everyone else, I will take your questions. Thanks, Andrea. Thank you, guys. Good. Tell me, all right, Andrea, I'm going to give you a little slack here, but do you understand, Andrea, why it is B and not any other answer choice? If not, I will do this over. Okay. So P is a prime number. How many different P's can you have? 2, 3, 5. That's it. Okay, there are 2 ways to get it. You can either count up through the prime numbers, or you can prime factorize and see what the bases are. Okay? Cool? Awesome. All right. Let's erase and move along. How to translate words into math. The GRE will give you word problems to solve using math. Math is a powerful tool. You can use it to describe relationships and solve problems that at first glance you might not think you can solve. So the classic age problem. June and his 2 older siblings are each 2 years apart. So great. 2 older siblings. So they could be 6, 8, and 10. They could be like 34, 36, 38. I don't know. If all 3 siblings' ages add up to 45, how old is June? Ooh, interesting. So here, what do they add up to? Well, 24, sorry, 14, so add up to 24. Here they add up to something ridiculous. So they gotta add up to 45, huh? Well, maybe it's that. So June is 13 years old. How did I get that? Well, 24 is 3 times the middle number. Whatever this is going to be 3 times 36. 45 is 3 times the middle number. So the middle child is 15. The youngest is 13. The oldest is 17. So June is 13 years old. This is pattern recognition. I have seen problems like this enough to know that when you have evenly spaced integers and you have 3 of them, the sum is going to be 3 times the middle. Okay? That's something that you will know after you have done all your homework. Okay? So this is how you translate words into math. Okay. So Dinesh has 7 times as much money as Jamila would have if Jamila gave 1/3 of her money to charity. Aha. So tell me what the left-hand side of the equation is. Tell me what the first thing you would do is. So go ahead and type it in the text box. What would you write about D and J? D and J. I see a hand going up. That hand is Whitney's hand. Whitney, tell me in the text box. What would you do? What's your idea, Whitney? Tell me. Tell me what you got. Dinesh has 7 times as much money. J equals 7D. All right, so Dinesh has 7 times as much money as Jamila. So 7 times as much as Jamila equals D. So what did you write? We wrote J equals 7D. That's exactly the opposite, and you can find that out because, like, what if Jamila had 70 bucks? How much does Dinesh have? Does Dinesh have 10 bucks? Or does Dinesh have 490 bucks? Okay, so figure out what that, using real numbers, what you really mean. So D equals 7J, but it's not as much money as Jamila has. It's as much money as Jamila would have if Jamila gave 1/3 of her money to charity. So Dinesh has 7 times as much as Jamila would have if she only had 2/3 as much as she has. And that's the relationship. Okay? Does that make sense? Would you get it on the GRE? Because if you wouldn't, I want you to do this at home. Erase everything and figure out what this is. Explain it in plain English to either a child, a pet, or a husband. They are equivalent in my mind, and you can explain it in plain English to either to any one of those 3 categories: a child, a pet, or a husband. Explain why the equation is D equals 7 times 2/3 J. You have to explain it out loud. You have to explain it so well that they understand why the equation is that. That is your homework, because then you will understand it, then and only then. 2/3. Why 2/3? So why 2/3? Because Jamila gave away 1/3 of her money to charity. So she owned, how much does she have left? She possesses 2/3 of her money. So 2/3 of what J is what Jamila had originally. So J is what she had originally, and how much does she have now if she gave 1/3 of it away? She has 2/3 of it. Does that make sense? She originally had all of it, and now she has 2/3 of it. And Dinesh has 7 times as much as what Jamila would have if she gave 1/3 of it away. Does that make sense? Great. Great, great, great. All right. we're sorry to lose Silvani, has to go, but Silvani, we'll see you next class, or if you can come back and join us, that will be great. All right. All right, let's finish this out here. Okay, let's try this. I want you to do one thing. I want you to substitute the number 50 for Z. Okay? Go ahead and try it out and see how you do. Go. Okay, guys, we're coming back, and I'm going to open the poll in 3, in 2, in 1, and go. Two more people, please vote. Mandatory voting. Australian rules. You must vote. Vote now. Please vote. Pick something. I'm going to close it in 2, 1. Okay. All right. So 2 of you, let's see, 50% of you picked B, and the others picked others. Okay. So I told you to use 50, which is a good number to use. Because you're dividing by 5 and you want to make it easy on yourself. So if Z equals 50, she saves 10 for upgrade. Oh, sorry, she uses 10 for frequent flyer miles upgrades. And then she saves 40 every month. So how long will it take Emily to save 25,000 miles? Well, she's saving 40 a month, and she needs to say, and she's going for 25,000. So how many months is it going to take her? She saves 40 every month, 40, and then 40, and then 40. So 25,000 divided by 40, that's going to be 1250. 1250 over 2, which is 625. Wow. That's a lot of months. Wait a minute. What is 625 in terms of Z? Z is 50. So that is 625 equals 50 times x. So 50. So that's going to be what? 625 divided by 50. Well, that looks like 12.5 to me. But let's solve this in a different way. Let's solve this using algebra. I'm going to erase this, and I'm going to say she uses z over 5, or 10, and she saves 4z over 5, Okay, so she saves 4/5, and she uses 1/5. Okay, how long will it take her to save 25,000 frequent flyer miles? Well, 25,000 divided by 4/5 z. That's how much she's saving every month. So multiply both let's see, 25,000 divided by 4/5 equals 25,000 times 5/4. So you flip it. So you get, I think this is, so again, this is 12,500, right? 2, and now you have 6250. That's right. So 6250 times 5. I think that is 31,250. And that's all over z. And that is B. So for those of you who got B, that's it. That was a pretty hard one. I tried using a simple number, and that kind of failed me. It wasn't helping me get there fast enough. So I went back and I went back to the original problem, and I said, she's using 1/5 on upgrades, and she's saving 4/5. Got it. So she's saving 4/5. So she's saving 4/5. How many months is it going to take her to save 25,000? Well, 4/5 every month. So divide 25,000 divided by 4/5 z. That's B. Any questions on that? Any questions? Okay, guys, we're just about done with algebra here. All right, sequences and series. This is a big one. This is actually a super, super, super important topic. People miss this stuff all the time, and I don't understand because it's super easy if you structure it right. And here's the deal with sequences, okay? I'm going to do this one with you. Follow along. So check this out. A sequence is just a bunch of numbers in a row. You have your first number, S sub 1, and then you have your second number, S sub 2, and then your third number, S sub 3, and then your fourth number, S sub 4, and then your nth number, S sub n. And it says a sequence, blah-de-de, blah-de-de, blah, is defined by k to the n plus 1. That means the next term is the first term plus 7 for anything bigger, for anything actually, for anything. If K4 is 19, then what's K3? Well, K3 plus 1 equals K3 plus 7. Oh, it's just saying that this term, 19, is the term before it plus 7. So what's the term before it? It's 12. You get that? So K3 plus 1, that's the fourth term, is the third term plus 7. And they tell you that the fourth term is 19. So the fourth term, which is 19, is K3 plus 7. The fourth term is 19 equals K3 plus 7. The third term is 12. So what's the second term? Is 5. What's the first term? -2. So which of the following expressions represents the value of the nth term in the sequence? Oh, so the nth term, like K3 equals 12. So let's find something. So n is 3. So we're looking for something where you use n as 3 and you get 12. So is 3 times 3 minus 7, is that 12? No. Is 3 times 3 plus 7 12? No. Is 7 times 3 minus 19 12? No. Is 7 times 3 minus 9, is that 12? Oh yeah. Is 9 times 3 minus 17 12? Nope. So the answer is D. Any questions? Questions on that? Guys, this is some hard algebra. Super important though. Super important. What are your questions? Why is n equal to 3? I just picked 3. It could be anything. So if I pick 2 as the second term, or as the nth term, what's the sub 2 term? That's 5. So then 5 equals k sub 2, and n equals 2. So then you do 3 times 2. Is that 3 times 2 minus 7? Is that going to be 5? No. Is 7 times 2 minus 9 5? Yeah. Yeah, it is. Where did I get the 3 again? I just picked any number. You can pick any of these expressions. Here's the thing. Put this stuff in plain English. Please, please put it in plain English. The first term, the second term is just a bunch of numbers in a row. If you use the jargon, you're dead meat. I know folks at MIT, I have classmates from Yale and Harvard, they speak in variables, in algebra, great for them. But most people don't speak like that, and if you don't speak like that, do not use the jargon. Say the first term. So it's if I use the third term is going to be 12. So which of the following expressions is going to give me 12 if I plug in a 3? Or which of the following expressions is going to give me a 5 if I plug in 2? Does that make sense? Whitney says, could you just use K4 equals 19 and go straight to the answers? Yeah, you probably could. K4 equals 19. So plug in 4. Is 7 times 4 minus 9 19? Yes, it is. So you can skip that whole first part, all the other stuff I did. You could. Very astute of you, Whitney. Very well done. Okay. Any other questions? You nailed sequences? Let's do it. Let's move on. All right. Ratio, proportion we did ratios, we did proportions, we did percents, we did divisibility, factors, multiples, primes, we did finding equations for word problems, and we did series and sequences. That's a lot of algebra. But if you know this stuff, you are going to crush the math part of the GRE. Okay, please do example 10 on your own, and we are going to move and example 11 on your own and example 12. That is for homework, 10, 11, 12. All right, here are your takeaways. There are a lot of different ways you can encounter this stuff. This stuff will be all over the GRE, I promise. So very, very important that you know this material. Here's your ready for homework. A lot of homework on this. Please look at slide 29 of lesson 3. Okay? We're going to move straight into lesson 4. Booyah! Algebra 2, my favorite algebra. Algebra, the sequel. Algebra Fast and Furious. Okay, here we go. We are going to do a ton of stuff in Algebra 2, but we are going to do it as quickly as possible while keeping you guys with me, okay? So the basis, the whole point of algebra is using letters for unknown values. So x's, y's, n's, a's, b's, and c's. Whenever possible, use real numbers so that you really understand what's going on. Because a lot of times, GRE uses x's and y's to confuse you because you do not speak algebra. It's okay. Nobody speaks algebra. Nobody pops out of the womb knowing how to do x's and y's. It's not a thing. So you explain the algebra in plain English and talk through it as you go through it. Okay? So let's try to make it as fun as possible. So an expression versus an equation. An expression has no equal sign. An equation must have an equal sign. That's the difference. So if someone says 3x plus 2, I can't figure out this equation. That person, not very good at math. Funny enough, because that's an expression. An equation has to have an equal sign. That's why it's called an equation. If it doesn't have an equal sign, it's called an expression. If your boss makes that mistake and says 3x plus 2, I can't figure out this equation. Ha 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 ha. Laugh. You should laugh with him. It's a very funny joke. Ha 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 ha. Look how little your boss knows. Ha ha ha. It's so funny. Okay, so if your younger sibling or subordinate makes that equation, rap him on the knuckles and correct him, but not your boss. Okay, so that is expressions versus an equation. Solving equations for a single variable. Keep both sides balanced. Always perform the same operation to each side of the equation at every step. Isolate the target variable, the one you're solving for. So let's see how it's done. Given P equals 2r plus Q over Q plus 2, solve for Q. What? That looks hard. Take it easy. Multiply by Q plus 2 to get rid of fractions. So P equals 2r plus Q. Q plus 2. Okay. Multiply by Q plus 2. Q plus 2. Q plus 2. So I'm multiplying both sides. So now I have Q plus 2 times P equals 2R plus Q, because these things cancel. Cool. Add and subtract to get all terms with Q alone on one side of the equation. Well, I want all terms with Q, so I'm going to distribute this P in. So I'm going to have PQ plus 2P equals 2R plus Q. Okay, and now I'm going to get PQ, I'm going to minus Q, I'm going to minus Q, and I'm going to have PQ plus 2P minus Q equals 2R. Uh-oh, I got a 2P on this side. I don't want 2P. Mostly because I peed before class, but excretory joke. Okay, so PQ minus Q equals 2R minus 2P, or not 2P. That is the question. All right, factor out the target variable. We got a PQ minus Q. So factoring out Q, I'm going to get Q times P minus 1 equals the mess on the other side, 2R minus 2P. And then I'm going to divide by P minus 1. Divide by P minus 1. And I'm going to get Q equals 2R minus 2P divided by P minus 1. And that's it, folks. That is the magic of algebra. Boom! Any questions on how that's done? Told you the dad jokes coming fast and furious tonight. Okay. I have a question. can I do step 3 again? Step 3, factoring out the target variable. So we had PQ minus Q equals 2R minus 2P. All right, I saw my Q here, and I wanted the Q out of there. So I made Q times P minus 1. Do you get that? Does that make sense? Okay, Andrea has got it. All right, I'll try to write more neatly for the rest of you. Apologies. Always do those 4 steps. In this case, yes, when you have those elements, you should always do those 4 steps. Yeah. When you have those elements. So we will see different kinds of algebraic expressions and equations, but when you have super complicated stuff like that, those are the steps. Those are the steps. Sometimes you need all those steps. Okay, so go ahead and try this one on your own. I'll give you a minute and 50 seconds. Go. Okay, folks, coming back, and we're going to test you. Here we go, opening the poll in 3, 2, 1, and go. Two more. Okay, one more person, please vote. All right, great. You split, an even split between B and C. Let's see here. Which of you is correct? A sporting goods store has a section that displays baseball caps, and each shelf in this section displays 10 caps. Cool. So this shelf has 10 caps. This shelf has 10 caps. This shelf has 10 caps. After 16 caps were sold, each shelf was left with 7 caps, except for the final shelf, which held 9 caps. Aha. Well, if there were only 3 shelves, then you'd cut this here. You would have sold 3 and had 7 left. You would have sold 3 and had 7 left. You would have sold 1 and had 9 left. So 3, 3, 1. So if you sell 3, 3, 1, you sell 7 caps. Huh. If you had another shelf, how many of the 10 would you sell? Oops. If you had another shelf, Oh, the final shelf has 9 caps. Oh, so that means that that other shelf is not the quote-unquote final shelf. You have 3 that you sold and 7 here. So this is what's going on. You have 3 plus, you have 3 times something, n, plus 1. Because you have 3 caps from every shelf except for the last one, equals 16. Cool. N equals 5. What is n? N is the number of shelves with 7 caps on them. So you have 5 shelves with 7 caps on them, and then you have that extra shelf with the 9 caps on it. So you have 6 total shelves. 6 total shelves. And that is the answer. Any questions on that? Any questions? No questions? Half of you got it wrong. Those of you who got it right, excellent job. All right, let's move along. If you have no questions, okay. All right, let's move along. Solving equations for multiple variables. All right, when you have 3x plus 2y equals 0 and 3x minus 2y equals -3, how do you find x's and y's? Well, there are 2 methods. You can either do substitution or combination. So to solve a system of equations, you need the amount of unique equations to equal the amount of unknowns. That is almost always true. So if you have 2 unknowns to solve for, you will need 2 unique equations to do so. I will caution you, there is one gigantic exception. When you have something like this, x plus y equals 2, and 2x plus 2y equals 4. You need to recognize that this second equation is the same thing as the first equation. Oh, it looks like 2 equations, 2 unknowns, but it is not. It is the same equation. That's the Twilight Zone sung in a register too high for human ears to recognize. So if you have the same equation, 2 unknowns, and really 1 equation, you can't solve it. Now what if you had x plus y equals 2 and 3x plus 2y equals 4? That's 2 equations, 2 unknowns. 2 different equations, 2 different unknowns, okay? But watch out for when they are the same equation. Okay, substitution. Substitute 1 equation into the other equation. So if you had x plus y equals 2 and x minus y equals -4, you could say x equals y minus 4, because you added y to both sides. So x equals y minus 4, and then plug that in to the first equation. So you get y minus 4 plus y equals 2. And then you have 2y minus 4 equals 2. And then you have 2y equals 6. And then y equals 3. And x equals -1. That's it. Any questions on that? That's the substitution method. If you have trouble with this, or if you are struggling with this, the book I want you to get and read and do and practice with over and over again is called Math Review for Standardized Tests. That is the book that will teach you fundamentals on your math. I have mentioned this before, but I mention it again because I am hearing lots of silence, which means you are either super bored or totally confused. So if it is the latter, please get Math Review for Standardized Tests. If you are super bored, please type in GRE for life. And I will not speed up, but I will give you GRE practice questions for life. That's a joke. Mostly, I will give you lots of GRE practice questions. Okay, okay. So substitution method. We just did a substitution method. We just did combination method. Okay, combination method. I don't think we've done one of these yet. Add or subtract two equations. So solve x equals y plus 6 and negative 2x equals 2y minus 7. Here's what you got to do when you're trying to combine equations. One of these variables, either the x or the y's, got to go. One of those has got to go. So we need to have them cancel out, basically. When you add them, they have to add to be 0, or when you subtract them, they have to subtract and be 0. So x and negative 2x. I can't add or subtract one from the other and get 0. Y and 2y. I can't add or subtract one from the other and get 0. So here's what I'm going to do. I'm going to multiply that first equation by 2. You hear me? So I'm going to get, here are my two equations now. On top, I have 2x equals 2y plus 12. And on the bottom, I have negative 2x equals 2y minus 7. And what I'm going to do is I'm going to add the equations. So 2x plus negative 2x is 0. 2y plus 2y is 4y. 12 plus a negative 7 is a positive 5. So I have 4y equal, 0 equals 4y plus 5, which means negative 5 equals 4y, which means that y equals negative 5/4. And then I plug it back into the equation. So x equals negative 5/4 plus 6. So that's going to be x equals 19/4. Right? I think that's right. So that is 4.75. 4.75, and that's what x is, and y is negative 1.25. Okay? That's it. All right. Now it's your turn. Here we go with the age problems. It's all you guys. I'm going to give you a minute and 50 seconds. Go. Okay, guys, coming back. And we're going to open the poll in 3, 2, 1. Go for it. Okay. Very interesting split here. We have 50% of you think it's D. We have a couple of B and C stragglers. So let's see what is going on here. All right. Edward is twice as old as Julia. That's our first equation. Edward is twice as old as Julia. If Julia is 10 years old, how old is Edward? He's 20. All right, that's how I double checked it. If you wrote J equals 2E, I bet you didn't check it. I bet you didn't say, if Julia is 10 years old, how old is Edward? Oh, he's 20. Yeah. Make sure you check it with real numbers. Super, super important. All of the best test takers check their algebra with real numbers. So Edward is twice as old as Julia. In 20 years, Edward plus 20, Edward will be 5 years older than 3 times Julia's current age. There you go. How old is Julia? What is J? So we got 2J. I'm going to replace plus 20 equals 3J plus 5. Minus 2J, minus 2J, minus 5, minus 5. Julia is 15 years old. That's it. That's the answer. Done. Good job to the person who got B. So you can check it. So Edward is twice as old as Julia, so that means that Edward right now is 30, right? In 20 years, Edward's going to be 50, and that's going to be 5 years older than 3 times Julia's current age. 3J is 45 plus 5 is that. Good. It checks out. That's it. All done. Any questions? You got to be good at that. The GRE will ask you that all day long. All day long. Got to do words into math. Okay? Any questions? Very quiet tonight. Very quiet. Okay. You guys are getting some premium personal attention. Use it. All right. Okay, Whitney, Jen, Andrea, Crystal. Let's do the next one. FOIL and factoring. FOIL, first, outer, inner, last. So you have A plus B times C plus D. So the first is these. First, A and C. Outer, A and D. Inner, B and C. And last, B and D. So A plus B times C plus D is first, outer, AD, inner, last. Okay, that is FOIL. Okay. Okay, it's the distributive rule. So how do you expand x minus 2 times x plus 6? First, x times x, which is x squared. Outer plus 6x, inner minus 2x, last minus 12. So x squared plus 4x minus 12. Okay? Cool. Factoring is the act of undoing the distributive property. So if you have 2 times x plus 3, that becomes 2x plus 6. Undoing it is factoring out a 2. Okay? All right. Common terms. Factoring this mess here. How do you factor that mess? Well, you take out stuff that's common. Here I see a -5 in both places. -5 Negative 5 times what? Times 1 times x cubed times y. Negative 5 times what? Positive 5 times x squared times y. What else? Oh, they both have a x squared in there. So you have negative 5 x squared times x y plus 5 times 1 times y. Oh, they both have a y in there, both of these terms. So negative 5 x squared y times x plus 5. And that is how you factor, using common terms. Okay? I'm going to skip the grouping for now and move along. Factoring quadratics when a does not equal 1, it's hard. This is super advanced stuff, and there are usually easier ways to solve it than learning this particular very esoteric lesson. So I'm going to skip this slide, but please refer to slide 18 if you ever see a question like this. And I will do this slide again, but this is very, very, very unlikely to come up on the GRE. Okay. When a does equal 1, you're going to see a lot of that on the GRE. So x squared plus something times x plus a constant. Well, find the factors of c that add to b. So if you have, down here we have x squared minus x minus 6. So minus 6, what are the factors that multiply to be 6? You got 3 and 2. And they have to add to be negative 1. Well, there you go. X minus 3, x plus 2. So x minus 3 times x plus 2 equals 0. So x could be 3. It could be x minus 3 is 0, in which case x is 3. Or it could be x plus 2 is 0, in which case x is minus 2. It could be either one of those. Okay? You're going to see that all over the GRE. And a equals 1. Okay. Common patterns. You got to know these 3 common patterns. This is the big one right here. That's called difference of squares. Why? Because this is a square, a squared, and this is a square, b squared, and you're subtracting b squared from a squared, or a difference. So the difference of squares is also factors to be a plus b times a minus b. You gotta know that, and you need to be on the lookout for difference of squares. A squared plus 2ab plus b squared is just a plus b quantity squared, and this is a minus b quantity squared. Knowing or recognizing these patterns can save a ton of time on test day. Okay, the more you practice, the more you're going to see slide 20 on lesson 4. Big time. Okay. All right, guys. Whitney, Jim, Andrea, Crystal, let's do this. I'm going to give you 2 minutes. Go. Okay, guys, this was a toughie. I'm going to open the poll in 3, 2, 1. Do it, rockapella. Wow. One more person. Go ahead and vote. In 3, 2, 1. There we go. All right. Good guesses. 2 of you got it correct. All right. How do we do this? Well, m and n are constants, blah, blah, blah. They're like some numbers. Hopefully they're easy numbers. And m is bigger than n. All right. Thank you. W squared minus 2 equals this mess, minus 1. Oh, interesting. So on the right-hand side, we got a minus 1. On the left-hand side, we got a minus 2. How can we make this easier? How can we get like this form? W plus something times W plus something else, and then we get a minus 1. Well, I'm gonna give the left-hand side that minus 1. W squared minus 1 equals W plus M times W plus N minus 1. Okay, because now we got this on the left-hand side, so we got W squared minus 1 on the left-hand side, and we got this on the right-hand side, so we got minus 1 on both sides. So now I'm not going to pay attention to this anymore because I got them on both sides, but bing, bing. And so now I got W squared minus 1 equals W plus M times W plus N. Why did I do that? Because I want the left-hand side's got to equal the right-hand side. And so there's this random minus 1 out there on the right-hand side. So I want to get a random minus 1 out there on the left-hand side. I did it. I did it. And now on the left-hand side I have W squared minus 1, and on the right-hand side I have this mess. What is this? Is there any way I can make this easy? Oh yes there is, because this is a square, W squared, and this is a square. 1 is a square. So this is a squared minus b squared is a plus b times a minus b. Sweet. So a squared minus b squared. So w squared minus 1 is w plus 1 times w minus 1 equals w plus m times w plus n. Okay, so that, and it tells you that m is greater than n. So that means m is 1 and n is negative 1. Sweet! I did it! What's the value of m? It's 1. It's 1. That's the answer. To those of you who got D, I'm very proud of you. I am super, super, super proud of you. For those of you who did not, did what I just did make sense? Was it sensical to you? Do you have questions about how I did that? Any questions? No questions? All right, I'm going to keep moving then. Here we go. Okay, go ahead and do this one. I'm going to give you 90 seconds. Go. Okay, this one was a bit easier than I thought it was, so I'm coming back and I'm going to open the poll in 3, 2, 1, and go for it. One more person, please vote. In 2, 1, and closing it. If you did not answer, I know who you are. Please vote. The whole point of the GRE is that you have to finish the questions. It's not a question of whether or not you get the right answer. You can get the right answer. It's a question of whether or not you can get the right answer in a constrained time limit. Okay? This practice stuff doesn't count. So, you know, it doesn't go in your permanent record, any of that. You need to practice choosing the answer and moving on. So, to the person who did not answer, please, when I say closing the poll in 2, 1, that's your signal, put in something and vote. Okay. Here we go. Given that x is between -2 and 5, is it bigger than 0? Well, quantity A says that x squared minus 3x minus 10. Huh. X squared minus 3x minus 10. That's interesting. So there are 2 answers to this question. So x squared minus 3x, that factors to be x minus 5 and x plus 2. So that means that x could be 5 or it could be -2. And it says x is between those numbers. What? So is it, what? Is it, A. Is quantity A an expression or an equation? Is it an equation? Did it say that x squared minus 3x minus 10 is equal to 0? There's no way to know what x is. So the answer should be D. I'm going to stick with that. I'm going to stick with D. So if you got something else, make sure you know the difference between an expression and an equation. So x squared minus 3x x minus 10 equals 0. Oh, that means that x minus 5 times x plus 2 equals 0. That means either x plus 2 is 0 or x minus 5 is 0. So that means that x is 5 or x is -2. But it doesn't say that. It doesn't say that in quantity A. It just says x squared minus 3x minus 10. Who knows? Could be anything. Okay? Be very careful. The GRE will do that to you. Okay, any questions on that? Any questions? Any cuestiones? Any preguntas? No? No questions? All right, let's hustle along. All right, quadratic equations and more. Quadratic equations have this form. We've been dealing with them all class long. You gotta multiply to something that results in C, and they have to add to something that results in B. You do not need to memorize the quadratic formula on the GRE. That is a fact. Solve equations by factoring. Move all terms to one side of the equation so that the other side is equal to 0. Factor equal to 0, just like we just did. Factor using any method. You can use common terms, you can use grouping, you can use quadratics, you can use common patterns. Once factored, you can use the rule that if something times something else is equal to 0, then either something is 0 or the other thing is 0. Okay, that's a really gobbledygooky way of saying that if x minus 3 times x plus 2 is equal to 0, either x minus 3 is 0 or x plus 2 is 0. If x minus 3 is 0, then x is 3. If x plus 2 is 0, then x is negative 2. Okay? That's what this gobbledygook says. Okay? Cool? Good. All right, solve x squared. So what do we do with this mess? Well, we got to get 0 on one side. So we get x squared minus 8x plus 15. So we got to get numbers that multiply to be 15 and add to be negative 8. How about 5 and 3? How about x minus 5 times x minus 3 equals 0? So either x minus 5 is 0, in which case x is 5, or x minus 3 is 0, in which case x is 3. So x could be 5 or it could be 3. All right, questions. Jin is says that the answer to the last problem might be something else. So Jin, type in your answer choice and type in a little bit why you think your answer is correct. I'm very curious to hear your reasoning. Okay. So Jin says B on the last one. And because I crave some student interaction right now, I'm going to go check this out. Why would 0 work? Why would 0 be bigger than quantity A? Why would that happen? I am checking. All right, so Jin says, go back to the last slide. Jin takes it back. X could be 0. All right. Jin, I'll tell you what. We will do this problem, just you and me, on Wednesday in office hours. So come to office hours, and we will do this problem over. I'm going to agree with Jin that B might be greater than quantity A. But the reasoning behind that is a little tricky. And I still think that this problem is so poorly written that D is a likelier and more probable answer. But as I said when I first started to do the question, it could be B. There's a case to be made for B. And we will cover that in office hours. So for today, let's finish up this quant lesson, okay? Okay. Go ahead and try this one on your own. I will give you a minute and a half, 90 seconds. Go. Okay, we are back, and we're going to open the poll in 3, 2, 1. Go for it. Okay, half of you said C, the other half said D. Let's check it out. Now, how many unique values of x does this whole thing equal 0? Well, I hope you got that you need to factor something out. So let's factor out an x squared. So x squared times x squared minus 4x plus 4 equals 0. So either x squared equals 0, so x could equal 0, or it equals something else. Well, what is x squared minus 4x plus 4? You know what that is? That's x minus 2 times x minus 2. So either it's 0 or it's 2. That's it. There are only 2 possible values, because you recognize that x squared minus 4x plus 4 is x minus 2 squared. That's it. And that is it. Any questions on that? Good job for those of you who got C. Okay, let's keep on moving. All right, go ahead and try this one. I will give you 90 seconds. Go. Okay, we are coming back, and we're going to open the poll in 3, 2, 1. Go for it. Okay, those of you who have not answered, there you go. We have an even split. Very good spread here. So one of you is correct. I promise. Let's see which one. Okay. So let's do it the easy way first. Here's the easy way. See what's on the bottom? 2 minus z. Look what's on the top. 3z minus 6. That looks a little suspicious. I wonder if we could factor anything out on the top. What if we could factor out a 3 on the top, and then we get z minus 2 on the top? Huh. Well, that doesn't help as much. Hey, you know what? I'll tell you what. I'm going to factor out something else on top. I'm going to factor out a negative 3. If I factor out a negative 3, then that becomes 2 minus z. Oh, that helps a lot. That was super good. If I factor out a negative 3, negative 3 times 2 is negative 6. Negative 3 times negative z is positive 3z. Sweet. What's on the bottom? 2 minus z equals 1 over z. Bing. Negative 3 equals 1 over z. So z negative 3z equals 1. Z is negative 1/3. Negative 1/3, negative 1/3, the answer is C. Okay, here's the hard way to do it. That's a super easy way to do it. That would be great. Here's the hard way to do it. Multiply everything like someone who is toiling, like a toiler. All right, 3z squared minus 6z, I'm cross multiplying here, equals 2 minus z plus z plus z minus 2 minus 2, and you get 3z squared minus 5z minus 2 equals 0. Yikes. That's super hard. 3z times z. This is the thing I told you would not need to know. Indeed, you don't need to know it. But if you insist on doing it, you can get 3z, I guess this is minus 2, and then this is plus 1. So z minus 2 and 3z plus 1 equals 0. That's going to work. So if you get z minus 2, you get z equals 2. So z could either be negative 1/3, which is correct, or 2. But guess what? Z cannot be 2, because you cannot have z as 2, because 2 minus 2 is 0, and then you are going into the abyss. Into the abyss. So 3 times 2 minus 6 divided by 2 minus 2. You cannot have that. That is cray-cray. That is 0 over 0. The Earth implodes on itself. You cannot divide 0 by 0. Not on the GRE, not unless you are at MIT, not you, not me, not in a tree, not for free. No, no, no. You cannot divide by 0 on the GRE. Don't do it. So the only answer is this one, negative 1/3. That's it. And that is the same in either column. Okay, so it's C. Any questions? Any questions? Yes? No? Okay, moving forward. All right, functions and symbolisms. This is the same thing as the sequences and the series. Fancy symbols and like gobbledygook keyboard strokes to confuse you. Do not be confused. Do not be confused, students. Focus on plain English. When I bracket A, that just means I'm doing a 1 over A and it's minus 3 times it. So when I bracket 2, what the heck am I doing to it? Well, I'm doing 1 over it minus 3 times it. That's it. That's it. What if I bracket 100? Well, that means I'm 1 overing it minus 3 times it. That's it. That's the whole thing. That's all it means. It just means when I bracket something, I'm doing this to it and I'm doing that to it. That's all it is. That's all functions are. Okay, so do not freak out. Do not let the strangeness of the terminology fool you or lead you astray. That is the biggest thing on symbolisms. Okay? Andrew says every time, and I say every time. Every time. Jin had some questions on the previous one. Nope, that was something else. Okay. Anything else on symbols? Every time? Every time. Okay. Let's erase and move forward to symbols. Given that A upside down triangle B equals A times B, what's the value of 2 upside down triangle 3? Type it in. Type it in. What do you think it is? What do you think it is? Yep, Andrea got it. Crystal, you nailed it. Whitney, crushed it. Jin, I know you got this. Jin, type it in. Type it in, Jin. Jin, type it in. Got it. All right, I'm going to assume that Jin has it. So the answer is 6. So great job, Jen. All right, given that x square y square z is that whole mess, if n squared 6 squared 9 is 0, what is the value of n? Well, all you do here is just replace the digits. So n square 6 square 9. So that means I'm doing n squared plus 6 times 9 plus 9 equals 0. So that's n squared plus 54 plus 9 equals 0. N squared plus 63 equals 0. Ruh-roh. N squared equals negative 63, and this is not a likely GRE question. So this is asking you to square root a negative number, which is mathematically possible, but you have to use imaginary numbers. And they're not going to ask that on the GRE. So not the greatest of GRE examples, but that's how you would solve n. And just the whole point of this is don't get freaked out by the symbols. Just plug it in. Plug it in. Let's see a real example. Go ahead and try. This one's a little hard, but this is the one we got. I want you to do it. I'll give you 2 minutes. Go. Okay. Let's see how good your guessing game is. Ready? I'm going to open the poll in 3, 2, 1, and go. Wow. You guys are great. 3/4 of you nailed it. So however you got it, I don't even care. I'm super proud of you. Very, very well done. It is B. That is it. So for which of the following functions h of x is h of x equal to h of 2 minus x for all x? So I'm going to say h of x is the h of 2. So h of 2 minus x, h of 2 minus x is the h of 0. You could also say that it's the h of 4 and the h of -2. But this looks like an easier thing to deal with. So h of 2 here is 1 over 0. Uh-oh, that's going to be bad. I'll tell you what, you know what else I can do? H of 1 is equal to the h of 1. That's not going to work. H of 0 and h of 2. H of 3 and h of -1. All right, so h of 3 is 1 over 1. So h of 3 is 1. H of -1 is 1 over -3. So that's not going to work. H of 3 is 1 over 4 minus 3 squared, which is 4 minus 9. Right? So that's 1 over 4 minus 9. So 1 over -5. And h of 2 minus 3, h of -1, is 1 over 4 minus -1 squared, which is 1. Uh-oh. 1 over 4 minus 1, 3. Uh-oh. I don't know. So, I don't know that B is right all of a sudden. So h of, so I would keep going through these and test maybe 2 and 0 or 3 and -1. H of x equals h of 2 minus x. H of 2 minus x is 3. 2 minus 3 is h of -1. H -1. All right. The answer key says B. 3/4 of you got B. I am curious. So here's what we're going to do. We're going to cover example number 7 in office hours next week. We're also going to cover example number 3 in example number 4. So we can cover 4 and 7 in office hours. Before we leave today, here's what I want to do with you. We're going to start with XY plane. We're going to finish XY plane, points, lines, and slopes next time, and then we're going to do all verbal. So here's what we're going to do on Tuesday. We have XY plane. That's going to take a half hour, and then we're going to do verbal the rest of the time. Today was tough. We did a tremendous amount of algebra. We did a ton of fundamentals. Some of the stuff was so hard that someone who has scored 99% on the GRE and 21 different tests, had some trouble explaining in plain English exactly why some answers were the way they were and exactly how you would figure it out in 2 minutes or less, or in a minute and a half or less. You know what? This stuff is hard, and I don't mind if you have some challenges with it, and I actually don't mind if I have some struggles with it either, because it means that I'm exercising the muscle, and it means I'm learning to react and process information. I miss things a lot on the GRE, but I very rarely choose the wrong answer, because you can miss something, you can miss a little thing, and if you catch it before you mark an answer, it's fine, as long as you do it in time. When we talk through things in office hours, I want to teach you how to miss things, I want to teach you how to catch things and how to say, uh-oh, I thought what I did was right, but it's not working out. So how can I pivot? How can I change direction? How can I find the right answer in the time I have left without panicking? All right, guys, this is your homework. Your homework is Algebra 2, sets 1 to 3, and the problems that we did, problems at the very end of Quant Lesson 3. If you have questions on the GRE or any practice, please email me directly. My email is maltzer@gmail.com. You can email me anytime. I will get straight back to you. Thank you, guys. Thank you, Andrea. Thank you, Jen. Thank you, Crystal. Thank you, Whitney, for coming tonight. I'm going to see you Tuesday night. We're going to do a little bit of algebra, and then we are going to dive into verbal. I'm looking forward to seeing you then. Have a great weekend, and enjoy the late summer / early autumn, depending on where you are. And if you are anywhere in the path of Irma, stay safe. If you are not in the path of Irma, also stay safe. And the best way to stay safe is to do GRE practice. I'll see you guys Tuesday night. Good night.